Lesson 15, video number 3. In this video, we're going to look at example 11a through f as well as 12. Okay. Now, with this particular set of information, we have to remember all of the composition of trig function information from the previous page of our notes. Okay. Again, once remembering that I can only plug in the values between -1 and 1 into the inverse trig functions of sine and cosine, any real number into the inverse tangent, but reverse, I can only plug in values between -pi/2 and pi/2 for sine, 0 to pi for cosine, when they're being plugged into the inverse trig function. Okay, so hold on to this information, utilize it when we're going through these problems. Now, I'm going to do it right on this piece of paper rather than use an extra paper at this point, okay? Which means I'm going to have to zoom in close enough so you can see the values. Now, sine of sine inverse of 0.357. Well, we've got to remember that the values that I can plug into the inverse function, again, into the inverse function, are -1 to 1. What set of values is this? Is it in there? Yes, it is. So that means I'm going to do the sine of the sine inverse of that. And for our actual set of rules, this is simply 0.375. Okay? Again, this is only true because the inverse trig function can take in the values between -1 and 1, and 0.375 is between those two values. Okay? Let's take a look at the next one. Cosine inverse of cosine of 3. So the question we've got to ask ourselves is, what set of values can be plugged into here that can then be returned into here? Well, cosine inverse, that set of rules is this fourth bullet right here. Okay, so again, if 0 is if 0 is less than or equal to x, less than or equal to pi, then cosine inverse of cosine of x is equal to x. Well, for the cosine inverse of cosine of 3, that is during that property, and the question is 3 between 0 and pi? Well, pi is 3.14. So, yes, 3 is between 0 and pi. So this thing would just spit back the value of 3. Again, all of these identities are, notice, sine of sine inverse is equal to x, cosine of cosine inverse is equal to x, tangent of tangent inverse is equal to x. They're all equal to x. So whatever it is I plug in, I'm getting back. Okay? Let's look at the next one. We have tangent of tangent inverse of -11.27. Now the question I've got to ask myself again is, what values can go into the tangent inverse? Well, the tangent inverse function actually takes in any value. Okay, it takes in any value. If that's the case, that means that it's going to spit back an angle measure. The tangent of that is going to actually invert that back to 11.27. Okay, negative of that. Okay, sine of sine inverse of pi. So the question on this is, does that make any sense? Again, think about it very clearly. In the last video, I mentioned that every inverse trig function takes in a number and spits out what? An angle measure. Every trig function takes in an angle measure and spits out a number. So in terms of pi, it's supposed to be an angle measure, okay? Sine inverse of pi. But that's the inverse trig function of an angle, not of a number. So this actually doesn't really make very much sense. But let me really go to the set of rules that we have for sine of sine inverse. Again, sine of sine inverse is this top one right here. And that's only equal to x if I go between -1 and 1. Where is pi? It's not between those two values. This right here would be considered undefined. Okay, again, it's undefined specifically because pi is not a value between -1 and 1. Okay, and sine inverse cannot take that value in. Okay, it cannot take that value in because it can't spit anything back out based on the way that we have defined the inverse trig functions. Okay, cosine of cosine inverse of 0.227. Again, what can I plug into the inverse cosine function? And that's the values between -1 and 1. Is this between -1 and 1? Yes. So this is simply 0.227 because the cosine and cosine inverse cancel each other out. Okay, last one before I move on to 12. It's the tangent inverse of tangent of 4 pi over 3. And the question is what set of values can I plug into tangent that can then be plugged into tangent inverse? Okay, and if we look at our set of rules, okay, it is tangent inverse of tan of x is equal to x. When does this occur? Between negative pi over 2 and pi over 2. So the question is where is 4 pi over 3? Well, 4 pi over 3, isn't that 3 pi over 3 plus a pi over 3? Isn't that something larger than pi? Again, it's something larger than pi. That's not between negative pi over 2 and pi over 2. Okay? It does not make sense for this particular thing to be defined. Okay? However, there's some information that we can use here. Okay, let's talk about what is the tangent of 4 pi over 3, really. Okay, well, 4 pi over 3, where does that sit? That's going to sit, let's see here, there's 1 pi over 3, no, I'm sorry, 1 pi over 3, because it's 1 pi over 6, 2 pi over 6. I'm going to zoom out for this so you can see the actual, what I'm doing here. I'm just redrawing the unit circle again. 1, 2, 3 pi over 6, 4, 5 pi over 6, sorry. Yeah, 1, 2, 3, 4, 5, 6 pi over 6, 7 pi over 6, 8 pi over 6. This is actually our 4 pi over 3. Okay, and you'll notice that this actual tangent value, okay, is positive, isn't it? I mean, this is sine, this is tangent, and this is cosine. Okay, so tangent is positive in this particular quadrant. And the set of values there, I don't quite remember, but what I'm going to do is I'm going to say, isn't that actually the same set of values that's over here in this first quadrant? What I'm trying to make here is, isn't this reference angle right here, okay, isn't that really just pi over 3? Again, that's a reference angle of pi over 3. So I can consider that similar to the reference angle over in that side. Well, if I compare it to that reference angle over in that side, I can say, well, these two actual trig values for tangent are exactly the same. So what I'm saying here is the tangent inverse of tangent of 4 pi over 3 is supposed to be equivalent to the tangent inverse of the tangent of pi over 3. The thing that I'm utilizing here is the fact that reference angle theorem, okay, the fact that I can take an angle plugged into a trig function, manipulate it, and compare it to another one, okay, is actually okay to do. Again, I'm saying that this angle over here is actually equivalent to this angle over here in terms of the tangent function. So I can make that substitution in my problem. And now I have the tangent inverse of tangent of an angle that's between negative pi over 2 and pi over 2. Therefore, this thing right here, okay, should be equal to pi over 3. Again, be very careful when you say something is undefined. Now, this one way up here was clearly undefined because the values for sine inverse that I can plug into sine inverse are between negative 1 and 1. There is no argument for any other way to do that. Now, if I'm looking at, you'll notice, a tangent on the inside, not the inverse trig, okay, the actual function. If that's actually inside the inverse function, what I can say about this is maybe I can transition this to another value that will work more effectively for me. And that's what we did in 11F. Okay, last one. We're going to look at this one right here. Now, these ones are very, very important. And they're not terribly difficult if you're careful. Okay? So, back up here, okay, I was making the statement that every inverse trig function, so I'm going to write this down. If I look at the cosine inverse of 2/5, it's supposed to be equal to what? Let me move this over. It's supposed to be equal to an angle measure. So I'm going to call it equal to theta. That means what am I looking for here? What is this? If I let this inverse trig function equal to theta, then this is sine of, well, the inverse trig function, which I said was equal to theta. So this is really what I'm looking for. What is sine of theta, given this is true? Well, let me take the cosine of both sides. And because 2/5 is between -1 and 1, the cosine inverse, okay, inside of the cosine function will actually spit back 2/5. Okay, so you'll notice here, these two things will actually cancel each other out. That'll leave me with 2/5 is equal to cosine of theta, and wait a second, what is cosine of theta again? And when I ask that question, I'm asking in terms of the triangles, not necessarily the unit circle. Why? Because I don't know when the cosine of theta is 2/5 in the unit circle. So let's start with the triangles. In my triangle, I have theta, cosine is adjacent over hypotenuse, and all I got to do is find this value over here. What's that value? Well, it's going to be 25 is equal to 4 plus, I'm going to just call it a squared. This is my a over here. I'm going to solve for a, and a is going to give me the plus or minus square root, but we're just going to ignore the negative case, and I'm going to have 25 minus 4, which is 21. That's not going to be simplified, so this is the square root of 21. And the way that we finish this problem is by simply saying, what is the sine of theta in this triangle? Well, sine of theta is this, again, the opposite over hypotenuse. So this is equal to the radical 21 over 5. And we're done. Okay, again, very carefully, I'm saying the inverse trig function is equal to an angle measure. If it's equal to an angle measure, then I can just go ahead and replace it with that thing, that theta, that alpha, beta, whatever you want to call it. By doing so, I can create my triangle based on this piece of information. By creating my triangle on this piece of information, I can find sine of theta. We're going to go ahead and do one more problem on this video. I believe we'll have time. Okay, it's very similar. What we're looking at now is the sine of sine inverse of plus cosine inverse. Now, this we cannot do as one entire problem, okay? I'm going to have to go ahead and call this alpha, and I'm going to have to call this beta. What I'm doing here is I'm saying every inverse trig function is equal to an angle measure, okay? So this should be sine of what? Alpha plus beta, okay? So now all that's left is for me to find out what the heck alpha and beta are. Okay, if I can find out what alpha and beta are, I'm done. Well, by doing this, what I'm going to do is I'm going to go ahead and transform this into the actual stipulation I had before. The sine inverse of 3/5 is equal to alpha. Okay, therefore my sine of alpha is equal to 3/5. Creating my triangle, I get a 3, 4, 5 triangle. Okay, again 3, 5, this must be 4. This is for the angle of alpha. So now let me go ahead and do the same thing for beta. Okay, cosine inverse of -5/3 for beta. So I have the cosine inverse of -5/13 is equal to beta. Okay, with that means I have the cosine of beta is equal to a -5/13. Well, if that's been done, then let me go ahead and create that triangle too. I have beta, and cosine is supposed to be 5/13. And because this is negative, now keep in mind, because that's negative, the non-hypotenuse side will also be the negative. Okay. Well, if that's the case, isn't this one of those other triangles again? I don't remember. 269 minus 25. That's 144, isn't it? Isn't this a 5, 12, 13 triangle? Okay. So with that stipulation being done, it's just a matter of saying, well, what the heck is sine of alpha plus beta? I have the two triangles. Okay. Now all I have to do is determine what sine of alpha plus beta is. Well, I don't remember how to do that. I don't know what these angle measures are in these two triangles. So what I'm going to do is I'm going to go ahead and see if I can find my formula sheet here and say, well, sine of alpha plus beta, that's just my first identity right here for sum and difference. I can change this to sine of x cosine of y plus cosine of x sine of y. So I'm going to go ahead and do that. This is really equal to the sine of alpha cosine of beta plus the cosine of alpha sine of beta. Okay. By making that transition, I can now find all my trig values in terms of these triangles over here and plug them in. So, sine of alpha we already have, that's 3/5. Cosine of beta we already have, that's -5/13. This is plus cosine of alpha. Cosine of alpha in this triangle is going to be 4/5. And then we have sine of beta. In this triangle is going to be 12/13. I simplify and I am done.